Welcome back to another one of my videos. Today will be a quick video showcasing how you can use the ESP-IDF framework and U8G2 library to display on monochrome OLED like this. But first, let me explain what the U8G2 library is about and why I recommend you to use it. We all know that there are a lot of cheap monochrome displays on the market. They are made by different vendors and have different controllers. For example, the two controllers SH1106 and SSD1306 seem to be two of the most common ones. The SH1106 has an internal RAM of 132 by 64 pixels instead of 128 by 64 of SSD1306, so they have different pixel mapping despite the fact that both screens have a resolution of 128 by 64. What makes U8G2 so great and commonly used is the support for so many different controllers and hardware, making it suitable for the vast majority of different displays used in embedded projects. The library has an abstraction layer that deals with these controllers under the hood, and all you have to do is to look at the easy-to-understand reference manual here, link in the description, and use the proper API command to control the display to your wish. The API provides a good amount of drawing primitives like drawing circles or geometrical shapes to make your work easier. So now that you see the point of using this library, let's see how we can set it up. The problem is that this library isn't written for a lot of MCUs or microcontroller units, and that includes our ESP32. It assumes that there will be functions that it can utilize in the MCU to control the display or interface with the display. That's where this hardware abstraction layer, or HAL, comes into play. It maps all the functions the library intends to use to correct API of the MCU, in this case the ESP-IDF framework of the ESP32 for controlling SPI, I2C, etc. This repository is forked from the original Colban ESP32 snippet for UG82 library, and I've personally tested it out and see that it does work on ESP-IDF version 5.4 that I'm using. Here is the process of how you can use it. Let's start with creating an ESP-IDF on Visual Studio Code. Now you will create a folder called Components. I have encountered troubles when using the Manage Components directly when using the library, so just create a new folder. Now we move to that directory and clone the original U8G2 library and the U8G2 ESP-IDF. The CMake list of the U8G2 library, I repeat, the library, not the one in our project, will be copied and pasted from this file right here. I have put the GitHub link of this file in the description. Now in our CMake list file in our main folder, you will include the two previous components. The names of the components are the same as the folders themselves. Since these displays normally work with either SPI or I2C, I'd recommend that you also include the driver depending on the display. Mine use I2C, so I'll include the I2C driver. Now that we've done setting up this library, let's see how we can use it. Include the header file as follows. We set up our hardware abstraction layer struct with the proper configuration, then created the U8G2 struct that stores the display data itself. The I2C address should be shifted one bit left, so normally my address is 0x3c, but here it must be 0x78. Use an online bit shifter if you have a different address in hex format. The setup function should match the controller you have. Looking at the U8G2 library setup files, you'll see that there can be multiple setup functions for the same controller, so if you're unsure, just test eval them out. Once you have initialized your display, you can do as you wish, but note that you check the C reference manual for coding in C, not the C++ one intended to be used on Arduino. Here, I'm using a resized image of the YouTube logo converted to bitmap, then pasted into this image to CPP web that converts the bitmap to byte arrays for monochrome display. Notice that the swap option is enabled if you are working with U8G2. This is also how we can display bitmap images on the display. We can copy the code but remove the prog mem keyword as it only exists for Arduino. I will create another button with the shadow shown here. The U8G2 library works by storing display data in the buffer and then sending it to the actual physical display, which is why it needs the send buffer function here. I can keep displaying bitmap consequently like this to display a short animation that you've just seen. There is only an extra step that I clear the buffer once each frame finishes displaying. And that's it for this video. Thanks for watching, and as always, you can support my channel by dropping likes and subscribes, or even consider giving a small donation with my info under the description. Hope to see you again in my future video.